Good morning, students. Yeah, today we are going to solve a problem on penalty method. Already we know how to solve a problem using your elimination technique. Now today my problem is on penalty method. A simple stepper bar I have taken. Now just read the problem first. The figure below shows a compound bar loaded as shown. Determine nodal displacement, stress in each element, reaction at T, support using penalty method of boundary conditions. Now what is given? One is Young's modulus for steel material is given, that is 200 GPa. And then Young's modulus for copper is given, that is 100 GPa. And then steel material with a diameter of 60 mm, copper material with a diameter of 40 mm. And that means area is not given, but diameter is given. Then load is applied at node 2, load is applied at the center, that is 100 kilonewton. And then length is given, length of the steel bar is around 800 mm, length of the copper bar is around 500 mm. Then direction of X, I am taking in this direction. If you are not given, you can assume it. If you are given, follow the whatever the direction is given in the problem. Now, see, according to the direction, we know how to do the node numbering. Always start from this side towards, always 2 towards the direction of your X. Now 1, 2 and 3, because of 2 steps are there, I am going to select it as in 2 elements. Now before going to solve my problem, first whatever the required data is, generally if you want to determine element of stiffness matrix, area, Young's modulus and length of the element is required. If you observe, length of the element is known, Young's modulus is known for both the materials, but only thing is area is not given but diameter is given. To calculate area, use your normal formula. We know that how to calculate your, this is a circular rod because diameter is given. We know that how to calculate area will be equal to pi d square by 4 cross section area. Now calculate what is the area of steel material. Now I calculate here pi into 60 square divided by 4, 2827.4 mm square. Then area of the copper, pi d square by 4, 1256.6 mm square. Now area is calculated. Steel material is given, what is Young's modulus, and copper is given. Is given in the form of 200 GPa, 100 GPa. I am converted to 2 into 10 power 5 Newton per mm square and 1 into 10 power 5 Newton per mm square. That is for steel and copper. Now what is our first step in a problem? It is almost similar to your previous problems what you have solved. First step is finite element model for continuum. You know how to make a finite element model. See, whatever the given is that represent in the form of a nodes and nodal displacements and its force. Okay, what are the forces acting at the particular point, or forces that may be subjected at which nodes. Okay, now if you take that concept, now we know that how many number of nodes? I can locate 3 nodes, 1, 2 and 3. Then the displacement I am going to get generally at node 1, Q1, Q2, Q3. Then forces I may expect is, what is the force acting at node 1, node 2 and node 3. Now this is a continuum. Now I convert it into your FEA model by locating only nodes and elements. Now if you observe, I have 2 elements. This is a 1 element and this is your second element. That means in between 1 and 2 I taken as a first element, in between 2 and 3 I taken it as a second element. Now this is the basic data required, I read down, and this is the basic data I written. Now after this I had finished the step 1. Now next thing is I am going with the step 2. What is the step 2? Formulate elemental stiffness matrix. What is the type of element given? It is a bar element. We know what is the elemental stiffness matrix. Ke is equals to AE by LE 1 minus 1 minus 1 1. Now what is that? We have 2 different materials. One is steel, that is Ke1, that is steel material. Now if steel material is given, we should know what is the area of steel material given, Young's modulus of the steel material, length of the steel, 1 minus 1 minus 1 1. Already we know this. What is the Young's area? Area is 2827.24 2827.24 into what is Young's modulus? 2 into 10 power 5 divided by, what is the length of the element? 800 mm. Then what is this? This is 1 minus 1 minus 1 1. Now if you calculate, you are going to get your matrix 10 power 5, keep it common. You are going to get a matrix 7.07 minus 7.07 minus 7.07 7.07. If you want to check it, just substitute in calculator and calculate it and check it. What is the area? 2827.4 into 2 into 10 power 5 divided by 800. 2827.4 into 2 into 10 power 5 divided by 800. You are going to get 7.06 into 10 power 5. Now I had written this, that is 7.068 is there, I had written like a 7.07. This is what I had calculated. Now after this, repeat the same step for calculating second element, that is made up of a copper. Now I am directly writing A copper, E copper, then length of the copper 1 minus 1 minus 1. Now what is A copper is given? 1256.6. Okay, 1 into 10 power 5 is Young's modulus. Length of the element is around 500 mm. Okay, then 1 minus 1 minus 1 1. Now if you take this, what is common? 10 power 5 common. Then I'll calculate what is the value? 1256.6 into 1 into 10 power 5 divided by 500. You are going to get 2.51. 2.513. That means I'll write here 2.51 minus 2.51 minus 2.51 and 2.51. Now just observe, this element belongs to what? Node 1 and 2, node 1 and 2. This belongs to node 2, 3, node 2, 3. Now if you've done this, what is the next step you should do? Formulate your global stiffness matrix. Now how to formulate global stiffness matrix? We know that K will be equal to, how many element of stiffness matrix will be there? K1 plus K2 because only 2 elements are there. What is the total number of nodes I am getting? See, 3 nodes are there. That means if I say observe row wise, I can see 3 rows. I can see if you observe column wise 1, 2, 3, row wise also 1, 2, 3. That means I can make that order of the global stiffness matrix should be equals to 3 cross 3. Or you can, using this matrix also you can decide. Otherwise, based on your number of nodes, we have 3 nodes. Each node I am going to expect only 1 displacement because of one dimensional element. Then order of the stiffness matrix should be only 3 cross 3. Now how to calculate this 3 cross 3? Keep your what is common in both the matrices. 10 to the power 5 is common. Now first write down order of the matrix. 1, 2, 3, 1, 2, 3. Now first I want A11 element. See A11 element, this is A11. Matrix wise A11 is that 7.07. 21 minus 7.07. 31, I think I don't have any element of 31 in both because 31 is not there. There is no 31 here. Now first row should be equals to first column. Write it this. Then come to second row. 2. What is this? 2, 2. What is 2, 2? Here is one element is there 2, 2. That is 7.07. Here also one element is 2, 2. That is 2.51. What is the value I can get? That is 9 point. Is it correct? 9.58. 9.58. Is it correct? 9.58. 7.07 plus 2.5. 9.58. Then minus 2.51. That is 32. Minus 2.51 because second row will be equal to second column and plus 2.51. Now this is called your formulation of global stiffness matrix. So if you formulated global stiffness matrix, then next concept will be your global force vector. Now how to calculate your global force vector and displacement vector. First we will finish displacement vector. If you observe your displacement vector, if you observe your problem, you know that how many displacement you can expect? 3. That means what is your displacement vector? Q1, Q2, Q3. This is your displacement vector. Now what is force vector? That is global force vector means it is a combination of 3 forces. What is the 3 forces? Traction force, body force and point load. But in this problem, traction force element is not present, body force term is not present. That means density is given, use the body force term. Similarly, if UDL is given, use your traction force term. UDL or UVL is given. But both are not given. Because of this, it will be 0. Then if you take your point load, only present is point load vector. Now this you should represent in a nodal format. That is F will be equal to what is the point load acting at node 1. If any point load is acting at node 1, no, that is 0. What is the point load acting at node 2? Yeah, point load is acting, that is 100 kilonewton. What is that? 100,000. Then what is the point load acting at node 3? 0. Just if you observe the problem, you only get it. See, observe this problem. What is the force acting at node 1? Any force is acting at node 1? 0. What is the force acting at node 2? 100 kilonewton. What is the force acting at node 3? 0. Okay, this is what the concept here. Now you got K, you got Q, you got F. Now next step is write your equilibrium equation for continuum. What is that? KQ equals to F. What is that? KQ equals to F? 10 power 5. First write your K matrix. What is K matrix? 7.07 minus 7.07, 0. Minus 7.07, 9.58. Then here minus 2.51. Yeah, minus 2.51. This will be 0 and this is 2.51. This is your K. What is Q? Q1, Q2, Q3. This is Q1, Q2, Q3. What is F? F will be equal to first node it is 0 100 kilonewton, that is 100,000. Okay, then it is 0. Now you got all the three. Okay, after calculating all the three, now comes to your next step is applying boundary condition. So this is what the difference between your previous problem and this problem. See, previous problem you are using an elimination method. What is the concept of elimination method? If any node is fixed, eliminate that corresponding row and corresponding column. So for this problem also, if in examination they won't mention any technique, always prefer your elimination method. If only specifies to do the penalty method, do the penalty method. Now what is penalty method? See, penalty method says that you can expect a displacement even at the fixed ends. This displacement will be very small. Very small displacements you are going to get. Okay, that means even at the fixed ends you can get as very small displacement. How to determine displacement at the fixed end? That concept will be explained using your penalty method. That means we are expecting a large stiffness at the your fixed ends. Large stiffness at the fixed ends. Large stiffness means what happens if you have a large stiffness, the deflection will be very small. See, that concept, based on that concept, we will explain. Okay, how to determine here? The penalty method means you should use a penalty value. What is penalty value? Penalty value is represented by a C. C is equals to maximum of Kij into 10 power 4. Maximum of Kij into 10 power 4. This is not, 10 power 4 is not constant. You can use 10 power 5 also, but minimum should be 10 power 4. Minimum should be into 10 power 4. See, maximum of Kj. What is maximum of Kj? Maximum of Kj means take a maximum value of your global stiffness matrix. What is the maximum value of your global stiffness matrix? 9.58 is the global stiffness matrix maximum value. What is that? 9.58 into 10 power 5, because 10 power 5 is outside, into 10 power 5 into 10 power 4. Now the maximum penalty value is 9.58 into 10 power 9. This is your penalty value. Now what you want to make with penalty value? See, add this penalty value to the fixed nodes. Add the penalty value C to the fixed nodes. What are the fixed nodes? Node 1 and node 3. What are the fixed nodes in the problem? Node 1 and node 3. Now, node 1 and node 3 means, what are the values of node 1 and node 3? So, you should see the matrix which having only node 1 and node 3 values. What are the node 1 and node 3 values? If you observe here, generally if you take a matrix, you have A11, A12, A13. What is A11 represent? The value which is belongs to only node 11. Similarly, A33 means what? The value which is belongs to only node 3. That means you should add a value of your penalty value C to the only A11 and A33, because A11 and A33 are called the values which will belongs to node 1 and node 3. Because if you observe another one, A21, what is the A21? It is a value connected between 1 and 2. 3, 2, it is a value connected between 2 and 3, like that. Okay. Now if you repeat this step, that means add your penalty value. How to add it? Now I keep 10 power 5 outside. I am taking this equation now. KQ equals to F, 10 power 5 outside. If 10 power 5 outside, this will become 7.07. So 10 power 5 outside means what is you want to add it here? 9.58 into 10 power 4 minus 7.070. Now minus 7.07, then 9.58. This is minus 2.51. Then come to the 0, minus 2.51. Now here, once again, you should add, because it is A33, you should add 9.58 into 10 power 4 into, what is there here? Q1. What is there here? Q1, Q2 and Q3. This is equals to, once again, what is this? Force. What is the force? That 0, 100, 1000 and 0. See, there is some changes has to be made here, but it will not applicable to this problem. I will explain that in the next problem. How even force also we can change. That will not is the concept here. That concept I will explain in the next problem. That concept will not come here. Okay. Next. After this, now how many equations you are going to get? You are going to get 3 equations. Use these 3 equations to determine your solution. Now, how to determine the 3 equation solution? Now, first see here. Now, I am going to expect a 3 equation. What is that 3 equation I write here? 7.07 plus 9.58 into 10 power 4. What is the answer I am going to get? I am going to get 9.58 into 07, 9.5807. See, just observe. I am going to write 3 equation, 10 power 5, 9.5807, into 10 power 4 into Q1 minus 7.07 into Q2. That means I'm making matrix multiplication. Okay, here 7 plus 0 into Q3 is equals to 0. This is my first equation. Okay, similarly I'm going to get next equation 10 power 5 minus 7.07 into Q1 plus 9.58 into Q2 minus 2.51 into Q3 is equals to 100 kilonewton. Okay, then this is equation number 2. Okay, then one more equation 10 power 5 0 into Q1 minus 2.51 into Q2. Then if you add those two, 9.58 into 10 power 4 plus 2.51, you are going to get 9.58 minus 9.58, sorry, not minus 9, plus 9.5802 into 10 power 4 into Q3 is equals to 0. That is equation number 3. See, this is what? See, whatever matrix you obtained, you got it. See, directly you can use calculator and you can solve it, because you know that how to determine 3 unknowns using your calculator. It is in the matrix format. Just type it in a matrix format and determine 3 unknowns, Q1, Q2 and Q3. That is the one method. Or solve the equations and you determine it. Now, if you solve these 3 equations, you are going to get 3 displacements. You are going to get the displacement. Now, the displacement what you are going to get is, first one is Q1 is equals to 7.699 into 10 power minus 6. Q2 is equals to 0.10435 into millimeter. Then Q3 is equals to 2.736 into 10 power minus 6. I told you what is the common here. You are going to get a small displacement, because it offers a large stiffness. If you observe the displacement, 7.69 into 10 power minus 6. 2.73 into 10 power minus 6. This is what we will do it in elimination method. Directly we will assume Q1 and Q3 as a 0 in elimination method. Why? Because we are expecting a very small displacement, because what we are assumed directly it as a 0. But here in your penalty method, we are showing that we are going to expect a very small displacements, because it will offer a large stiffness at that particular point. Got it? This is how you should determine your displacement. After displacement, next step is how to determine your strain value. See, to determine your strain value, very simple. First, write how to determine your strain value. Epsilon 1 is equals to 1 by LE minus 1 plus 1 into Q1 Q2. Directly I write down what is this? This is nothing but BQ. This is nothing but B. This is nothing but Q. Why element number 1? See, element number 1. What is element number 1? What is the length of element number 1? 800. That is steel. 800 minus 1 plus 1. If you substitute what is Q1 Q2? What is Q1 Q2? 7.699 into 10 power minus 6. Then what is Q2? 0.10435. You may ask me why Q1 Q2? Because element number 1 having a displacements Q1 and Q2. So if you solve this, you are going to get a strain value this much. Now, how to calculate your strain? Just repeat it. E sigma equals to epsilon 1 into E, or E into epsilon 1. That is nothing but EBQ. Already we know what is E. 2 into 10 power 5, because it is steel material, first element, into 1.304 into 10 power minus 4. You are going to get answer is 26.08 Newton per millimeter square is the stress. Now repeat the same step for calculating your second element strain. Epsilon 2 is equals to same BQ. What is BQ now? 1 by length of copper minus 1 plus 1 into what is the displacements of second element? Q2 Q3. Now substitute what is the length of the copper? 500 minus 1 plus 1. What is Q2 Q3? Q2 is 0.10435. 10435 and 2.736 into 10 power minus 6. If you determine this, you are going to get minus 2.086 is your strain value for second element. Similarly, sigma 2 will be equal to E into epsilon 2. E, you know what is E value? 1 into 10 power 5, because it is copper, minus 2.086 into 10 power minus 4. You are going to get a strain value. So you are going to get a stress value sigma 2 equals to minus 20.86 Newton per mm square. Then apart from this, next value what you want to calculate is how to determine your reactionality support. So to calculate reaction at the support, little bit different from your previous one. Now see, you don't have any eliminated row. Because of directly we should use a formula, that is R1. See, because node 1 is fixed, R1 is equals to minus C into Q1 minus A1 is there. Q1 minus A1. See why? But for this problem, A1 is not A1 equals to 0 because it won't come concept now here. A1 concept will not come into this problem because there is no any initial displacement at node 1 and node 3. Node 1, there is no any initial displacement at node 1. Because of that, A1 will be equal to 0. A1 is called as the initial displacement. Q1 is called the actual displacement what you obtained. Now R1 is equals to minus C. What is minus C? Minus C is your penalty value. What is the penalty value? 9.58 into 10 power 9. You use 9.5 and 10 power 9 into what is Q1? Q1 is you obtained Q1 value, that is 6 point. What is display? You obtained 7.699. 7.699 into 10 power minus 6. So if you multiply this, you are going to get a value of 73.79 kilonewton. 73.79 kilonewton. Repeat same thing even for node 3. Node 3 is R3 is equals to, because another fixed end is R3. R3 equals to minus C into, now what is the displacement? Q3 minus A3. Now here also A3 will be equal to 0 because there is no initial displacement at that particular point. Now repeat same thing, minus 9.58 into 10 power 9 into the obtained displacement at node 3 is 2.736. 2.736 into 10 power minus 6. So if you obtain, you are going to get 26,219.08, or if you take in kilonewton, minus 26.219. Just if you observe both, you can add it, you are going to get nearly 100 kilonewton. That means whatever you applied load is that the reaction has been split between two nodes. Now R1 you are going to get, this is the reaction, R3 this is the reaction force.